Welcome back to another Ramda JS video, and in this video we are simply just going to pick up where we left off last time. So we're going to continue this interesting journey of using Fantasyland compatible applicative functors with the Ramda function either, right? So as we can see here in the documentation, as we talked about last time, the function either that we described in the last video supports, or let me say, also accepts any Fantasyland compatible applicative functor. So if you have your own applicative functor, your own sort of data structure that is an applicative functor and it's Fantasyland compatible, then you can pass that to either, which of course is interesting, so we need to try this out. And I mean, just to recap, what we talked about last time is that this function either, essentially you pass it to predicates and it gives you a new predicate. So it's like you're giving two predicates and it constructs a composite predicate of these two predicates where you're using or with these predicates, right? So you're constructing a new function which is can be seen as a new predicate that when passed values will answer with true or false. And that true or falseness, that boolean, is based on whether either of your sort of input predicates are true or false given that value. But again, this we talked about in the last video. So what we're going to do now is essentially that we're going to use this applicative functor that we built in the last video, which is this class called box. And we're going to explore how we can use that with this function either in Ramda. So to be perfectly honest with you, you might have noticed that the last video was sort of abruptly cut off, but that's essentially because I spent like half an hour debugging while recording because I couldn't figure out how to actually use this applicative functor because there were two errors. We don't actually have a Fantasyland compatible applicative functor yet because of a minor detail. And the second thing was that I actually misunderstood how this applicative functor can be used with the function either. So let me just give a quick shout out to this guy called Ian, so EvilSoft at GitHub, because I entered the Gitter chat for Ramda in sort of desperate hope that somebody would be able to point me in the right direction of what I'm misunderstanding. And like, this guy obviously helped me out a ton by sort of pointing me in the right direction and sort of helping me figure out what I'm misunderstanding, right? So thanks a ton to Ian. But so okay, so let's start in I guess let's start in this end. Let's start by just saying what either does. So when you're passing an applicative functor. So when you're passing an applicative functor, either actually behaves like or, metaphorically, I think, or like, in my mind, it makes more sense to think of it that way, right? So think about or. So or takes one value and then one value and then gives you either true or false back. So it gives you something that's, like, it gives you something that's true or something that's false, and then something that's true or something that's false, and then it gives you, either true or false back. So if you have an applicative functor with either, what that does is that you have this boxed boolean. So you have a boxed either true or false value, and then you have another boxed either true or false value, and then you get back a new boxed true or false value. And we're going to look at this concretely, right? But this is sort of the intuition. So if you think of, if we assume that the applicative functor is called f, then the type signature would be something like f of a to f of a to f of either a or b. Or sorry, I said f of a and f of a. I meant, of course, f of a and f of b to f of a or b. But I guess, so let me just like write this as a comment here in the code. Like, I guess it would be something like this if we use bool instead. It's something like if f is an applicative, then the function has the signature that if you pass f of bool and then f of bool, you will get back an f of bool. Something like that, right? So if you have a... Sorry, I'm about to sneeze. Sorry, so stupid. So if you have a boxed value true and you have a boxed value false, and then you sort of pass those two things to either, then you will get back a boxed true, right? But then it's, of course, not exactly like that because of this notion of truthiness. So if since it sort of behaves like or, it's again, like there's this thing where if the first thing is true, then it's short-circuited, so you will get back the first value. So actually, like, I mean, this is, I guess we should say booly or something like that, right? It's like a bool-ish, right? Like anything that's can be truthy or can be falsy. And so yeah, I mean, what am I saying? Yeah, so what I was saying is that if this first thing is like f of 1, for example, then that would be truthy, and hence you would get back an f of 1. But okay, let's jump back to either. I mean, this is the type definition for or. And so then I'm a bit confused about why they've implemented, they've chosen to implement this function, or implement the support for applicative functors on the function either rather than the function or. But from discussing a bit with Ian in Gitter, and then somebody else chimed in as well, it seems that maybe on a type definition level, it's actually more accurate to say that the definition looks like either, right? Because it's so yeah, I mean, I wrote booly here, and I wrote bool with lowercase just to make it sort of look like either. Let me just say boolean like this instead, right? So we should think about it this way. It's like you have A to A to A, but it's, I mean, it's not really A, right? But it's like, given that f is an applicative, the function, the type signature is then that if you have an f of a boolean and then you pass an f of a boolean, then you get back an f of a boolean. So it's like if you pass something of the thing or something of the type and then another thing of the same type, then you get back another thing of that same type. And so that doesn't really correspond with the type signature of or, but it does correspond with the type signature of either, right? Because as you can see here, that sort of does the same thing. It's like start to boolean, and then start to boolean. And this is way beyond my knowledge, right? But I assume that there is some way of thinking about let's say an instance of a data structure as a function in a functional language. And this is, again, like, this is way beyond me, but I assume you can sort of think of that as a function, and then it would also make sense to think of it as a variation of the function either rather than of the function or. But then again, like, no, but yeah, that would make sense, right? Yeah, I guess something like that, because then it's like this star ... arrow would be somewhat equivalent to this f. So then it's like applicative f. Actually, I realized maybe I didn't expand parameters here. Do we see? No. Okay, so I was just considering that maybe they wrote something about the applicatives here as well. But anyways, so this is sort of the notion of, or this is the way we can use these applicatives, and we'll try it out and see what we can get out. But again, like in regards to why they've chosen to put it in either rather than in or, yeah, it seems like it's something along the lines of what I was saying. If you have a better explanation for that, feel absolutely free to put something in the comments. That would be very interesting to read. I mean, clearly there's more depth to this. It also has something to do with and this, I think, I can't remember. Maybe we looked at this last time. Let me just open up the source of either. It has something to do with being able to simply lift. Whoops. How do I, like this? Like if you just look at the implementation here, so this is the applicative part. So they lift or, and then apply f and g, or apply it to f and g. So probably this has something to do with it as well, but I don't know, right? It's better if I don't say anything. So let's close that. Let's go back to Ramda. And okay, before we're gonna go any further, let's work with our applicative, our box, right? So one thing that's interesting that came out of that discussion is also that this box that we've described, I actually think that that's commonly called the identity functor or applicative, depending on what you want to think about, right? Because if you think about it, I mean, the identity function, for example, or I guess like the identity morphism, is something that, let's say identity is a function that when given something of type A returns the A, and then the implementation of identity, so let me remember to use JavaScript, is something then like identity when passed x will return x. Wait, sorry, I keep forgetting syntax. Sorry, like that, right? so whenever you pass something, it just passes back itself. So like it does nothing. Like that's a way of thinking about identity. Like when you give it something, it just gives you back the same thing. It's like Nothing has been changed, right? But then you can think about identity as a sort of on the sort of wrapper level as well. Like, what would identity mean on the wrapper level? And then identity would probably mean just to wrap a value without doing anything to the value under any circumstances. And that thing can probably implement a lot of the different what should I call them? Let's go to Fantasyland specification. I'm searching for a word of like, algebraic structures, I guess. No. I should probably say interfaces or something like that. It can satisfy a bunch of different interfaces. Yeah, something like that. And actually, like, if we look at data.functor.identity, so identity from Haskell, for example. So now we're reading the Haskell docs, just like, because it's interesting, right? Because again, like, there are a lot of parallels between different languages, even if sometimes there are slight variations. Category theory is a fairly well-studied field, and hence there are a lot of similarities between the different languages. But anyway, so then you can see that, okay, we have identity as a type, and there are some instances of that, and these are, for example, monad functor, monad fix, applicative, foldable, and traversable. Actually, let's look, right? Like foldable and traversable, for example, if we go to Fantasyland specification, we have here, right? Foldable and traversable, but also functor, apply, applicative, monad. I don't think apply maybe exists in Haskell, not sure, but definitely applicative, right? So functor, applicative, and monad. Then there were few others, I guess, right? But let's not worry about that. So if we jump to if we jump to the source of maybe this wasn't visible. Let me do this instead so it's actually visible. So okay. So monad functor, monad fix, applicative, foldable, and traversable. Actually, sorry, monad fix was the only one I missed before. Okay, anyways, we want to look at the source of applicative identity. So let's go to the source here and let's see if we can find that, right? So we have instance of applicative identity here, and then we have the implementation for pure, and we have the implementation for the strange symbol, which is app, right? So pure in Haskell, or like for a Haskell applicative, is what's known as of. In the Fantasyland specification, and this strange symbol, which probably has a name that I can't remember, is app. So and then you can see, right? So, and I think wait, we need to remember that identity. Yeah, okay, we'll get to that, right? So pure A, so of, when given some A, is simply implemented as wrapping A in the type identity, right? So clearly that's of, right? It's the same implementation that we have, right? It's like static of, the way we implemented it, and if you pass an X to of, the only thing that we do is we simply just take that X and we wrap it in a box. Done. That's it, right? Which you pass me an X, I'll wrap it in the box. That's done. That's the implementation of. That's how you create a box from a value. Nothing special about it, right? So it's sort of the same implementation as here. And then let's think about this one then. So this symbol, I guess they've here defined it. Yeah, sorry, they've here defined it as in infix notation, right? So this is the name of the function. Here's the first argument, and here is the second argument. And so this first argument is, right, so assuming that this is an applicative over identity, then if you have a function, this f wrapped in identity, and if you have an x, so some value wrapped in identity, then the new the result of that will be the function applied to the value wrapped in a new identity, right? I mean, that's exactly what we are doing as well. Like, that's our implementation of app. We just say, I mean, it's like we map over the boxed function that was passed to us, but and when we do that, we take the function that's in that box and we apply it to the x. I mean, because of syntax differences, there are some slight variations, but like essentially we're doing exactly the same thing. So I thought that was interesting. Like, so I mean, we didn't just make up this silly box that is never used anywhere. It's actually in the, I don't know if this is in the prelude of, no, it's not in the prelude of Haskell, but yeah, I mean, it's in a module, but yeah, I don't know. I guess like base Haskell or whatever. Yeah. Anyways, it exists in Haskell essentially. Okay. So let's just rename this, right? So let's search for box and rename it to identity everywhere, right? Because I think that makes sense. We've essentially just described identity, so it should be called identity everywhere. Sorry, I had this console log statement here in the end. Let's remove that. Okay, yes. So that should work fine. And here we just have this comment. Let's maybe save that. Yeah, let's save that because we have like, this is the way you're using. Let's add to these comments instead, right? So this is like either with predicates. This is both with predicates. And then maybe let's put this on one line. Is that possible? Yeah. So, and then we should say either with applicatives. And then we should say both with applicatives. Okay? And then we remember that this is sort of the type definition of the function either given or when we're passing applicatives, right? I mean, it's like sort of correct, right? Yeah, and maybe I should like put the word either here, but we know that this specifies either. Okay, so that's that. Okay, we've renamed it to identity. Let's map a keystroke to running this file, and then make sure that we don't have any errors here. Yeah, sorry, let me clear the screen here because I was messing around a bit before. Okay, like that. And then you can see, I mean, we get some stuff back that we were printing before, and that's all fine, right? And those are actually, if I'm just dropping to the end of the file here, you can see that those are the things that we tried out when we were trying to make sure that our box was working correctly, essentially, which is now called our identity, right? And it seems like it's sort of still working correctly, right? 10, 20, 20, or like we get boxed values of 10, 20 because we have a box containing 20, then we just print the box, then we map a function that doubles the value over the box, and we get a new box with a doubled value. And then we use app on the box in order to map a boxed function that doubles the value. Maybe I should make a ×3 here just so we have different values, right? So identity containing 10, 10, identity containing the doubled value, and identity containing the tripled value. So that's all fine and good. Okay, what's the next problem that we need to solve? Well, the next problem that we need to solve is that we didn't actually fully support the Fantasyland specification. The reason for that is here. Let's go to the top. No, let's go downwards a bit. Let's see, notation, here. Prefixed method names. So in order for a data type to be compatible with Fantasyland, its values must have certain properties. These properties are all prefixed by fantasy-land/. For example, if you want to implement the function map and you have a thing called myType, then you can, to the prototype of myType, add the function fantasy-land/map, right? And that's how Fantasyland makes sure that, or ensures that they are not sort of accidentally interacting with a function that you didn't intend them to or a method that you didn't want them to interact with, right? So in some sense, it's like your types can have a map implementation and then a Fantasyland map implementation. I'm not sure why, right? I'm not sure why you would want that, but I guess this makes sense. It's like you're saying then, like, if something implements the Fantasyland specification, then it needs to explicitly implement the Fantasyland specification. Whether that's a good thing or not, I don't know, dude, right? But okay, so this means that we need to have very funky names. Instead of map, we need to call this function Fantasyland/map. And this, of course, we can't do like this in a class because it needs to be a string, and I'm not actually sure if you can do. I mean, can you do that? Let's think about that. Now, of course, map won't work because the function is not called map anymore. So can we say box and then call it like this, Fantasyland/map? Wait, map. Yeah, sorry, because here we are also calling map. So let's say like this, Fantasyland/map. Does that work? Yeah, that actually works, right? So I was actually going to, I was going to change this to sort of prototype syntax so that I could define map and app and of, and then add sort of aliases that run these methods instead, just for it to be a bit more clean. But I mean, doesn't matter, right? Like we could do it this way instead. So instead of calling it app, we could just call it Fantasyland/app. App like that. Because yeah, I mean, I'm hesitating to. I mean, another way of doing it would be to add another, like if we would say Fantasyland/app, and then like we need bf, and then the implementation of that would be return this.app bf. This doesn't feel very clean to me. It feels like we're sort of duplicating code. Yeah, no, I mean, actually, so this works fine. You could use the class syntax, but at this point, it just feels like it becomes a bit unclean to me. So I would suggest that we do this instead. We just say that const identity is a function that takes some x and assigns this dot x2 to the x that we're being passed in. And then we take identity, and then on the prototype, we add the function map, and it takes some function, and then we have this implementation, right? Where we say return new identity, where the function has been applied to the value that I'm containing, where the function has been, the function I'm being passed in has been applied to the value that I contain. And then identity, I really can't spell, prototype.app takes some function inside of a container, right? And now it's called bf, but maybe this should be called, so then maybe this should be called if. Okay, but let's say bf for like, yeah, that doesn't really make any sense. I mean, it's like f is usually used for sort of wrappers, but then it feels very strange to say ff, because if f is used for a wrapper and a function, it's like a function, or like, yeah, let me say bf. Maybe there's a better sort of convention to use here, and if you have one, please feel free to shoot that in the comments. Anyways, so we return, and then we have the app implementation, which we have down here on line 35, and that implementation is just return, what is it, this dot map, where we take the function inside the thing that we have, and no, sorry, the other way around. We say bf that we've been mapped, that we've been passed, and then because we call map on the box that we've been passed, and that means every value inside the mapping will be a function. So then we take that function and we apply it to the value that we are hosting in this container, or that we are wrapping in this container. Okay, and now this should be the same implementation, but then we also need the static function. So identity.of some x essentially just says return new identity of x, right? Same thing. That's the static function. Okay, so now we've replaced the class with this sort of old or classic prototype syntax. And if I change back here from, I mean, here we called it with the prototype, or sorry, with the Fantasyland syntax, but we could call just map here as we were doing before. Now I should be able to do this. Wait, a syntax error. I should have read the syntax error. Unexpected token 21 here. What am I? Identity is a function that takes some x, and then we open that up, and then we say, what am I doing wrong? This dot x is equal to x. Wait a minute, let me just remove this stuff and see what happens. That's fine, so that's obviously fine. So let's remove that. Unexpected oh, okay. Sorry, I'm mixing syntaxes. So of course I should have said identity.prototype.map is equal to a function that takes yeah, sorry, and then of course I need to specify function. So so silly. So I need to say function here that takes some f, and then of course I need to say app is equal to some function that takes a bf, and then identity of is a function that takes some x. Okay, now that should work. Silly of me. Okay, yeah, and that works, right? We get like the identity of 10, of 20, and then of 30. So same stuff as before. Now the reason I did this is that we can now define the, like, internally here within the module, like within the data structure, we can call our nicer methods, and we don't have to worry about this Fantasyland syntax because these names are sort of very, very long. But we can still add them by then saying identity and then identity and then Fantasyland/map is an alias for identity.map, right? So we're just saying that's the same thing. And then the same thing for app. Oh, sorry, and these need to be on the prototype. Dot prototype. Whoa, mal. Identity dot prototype, like that. And of course that needs to go here as well. On map prototype.app. Misspell. Prototype.map. Okay, and then we need to have identity dot not prototype but of nope, sorry, identity fantasyland of is equal to identity.prototype.of, right? So we're sort of just creating these aliases that specifies the like if you call one of these methods, or if you're using this as a Fantasyland compatible data structure, or in this case applicative functor, then the Fantasyland versions of these methods can be found here, right? Left-hand side maps to the right-hand side. So we're just saying these are the same functions. And I think this kind of turns out cleaner. But again, like, this doesn't really matter. I just did this because I think it's simpler to reason about this. Like, semantically, it's easier to see what's going on. So that seems to work fine. Then let's just check out if we can actually call the Fantasyland versions, right? So let's replace map here with a call to Fantasyland land map, like that, and replace the call to app with Fantasyland app, like that. Yep, let's run that, and that still works fine, right? So both of them seem to work. Let's jump backwards. I'm undoing backwards because we don't need that. And actually, let's remove these calls in some sense, right? Because now we don't need them because we know the functor sort of works, or the applicative functor works. So okay, now we're not printing anything, and we have this this applicative functor defined in the end of the file. Of course, what we need to do now is we need to move this up because it needs to be defined when we're going to use it, right? So that's our applicative functor, and then these are some helper functions that we used before, and let's use these again. And actually, these are used here in these examples, right? So this is when we used either with predicates. And this is when we used both with predicates. So what we want to do now is we want to use either with an applicative. And then remember that it's used slightly differently, because when we use either with predicates, we're sort of composing two predicates and producing a new predicate. But when we are using either, but when we are using either with applicatives, we are passing two applicatives that contain values that are truthy or falsy, and we evaluate whether the whole statement is truthy or falsy, or expression, I should say, sorry. And I guess, like, I was assuming that we would do something different. I would assume that we would, like, yeah, let's not talk about that because it just probably increases the amount of confusion. But I mean, like, I would assume that we have, like, two functions in applicatives, and then we pass a value in an applicative. But for some reason, that's not what we're doing. And I guess, I was thinking about this, I guess you need an applicative because you need the of method, because they need to be able to rewrap the thing. Like, if you just have map, if you just have a functor, it's probably difficult to create an implementation of either, or essentially it's difficult to create an implementation of or for boxed values. I shouldn't say difficult, I should say impossible, if you only have map, right? Because if you can't unwrap something, right? So it's like, then you would probably have a box of the value as a return thing, and you don't want that. You want a box of the thing, or a box of the value as a return value. So anyways, let's try this out, right? Let's say, let's just console log directly, right? So we'll console log, and what will we console log? We want to console log a call to either, and let's just do something simple. Let's say the identity of, let's say true, and then the identity of false. And then let's close that. Whoops, what am I doing? Okay, right? And then, actually, let me put this back on one line. I don't know why I didn't put this on one line. So like this. Like this. And then let's do the same thing, but for false and false. And then let's look at that. And here you can see, okay, in the first case, we get back an identity of true, and in the second one, we get back an identity of false, right? I'm actually, it just struck me that I'm wondering whether our implementation of identity actually would, let's say, be a valid implementation of the identity applicative functor, because we actually do have a bit more stuff here because we have this X thing. So maybe it's not even really possible to implement an applicative identity functor in, or like an identity functor in JavaScript, because we don't really, I mean, in Haskell we have this thing of like, you can say let me just do this as a comment, right? Like an identity of X, but that, you can't do that in JavaScript, right? In JavaScript it's like, well, there has to be an object, so it's like an identity, well, I mean, let's say val here, up here, right? Where it's like X points to the value. You can't just have the value like that. But anyways, I mean, this is a side note. Let's talk about that some other time. Maybe when we get to the Fantasyland specification. But anyways, okay. So yeah, I mean, hopefully you can see how this works, right? It's like we're saying R.either, and then we pass these applicative functors, identity of true and identity of false. And it's sort of, it's not really unwrapping, right? But it's probably using app. Like it's using our implementation of app to apply the function or to the values inside of these two identities. And again, if we think about app, it's using the function or. It's probably taking the function or and putting it and that's why it needs of, right? It's probably taking the function or, putting it inside an identity, and then using that. But how does it, but maybe through partial application. Yeah, through partial application, right? And then through partial application. And then it, so then we have two identities with values and one identity with a function that has an arity of 2. And then it uses app to apply one of the values inside an identity to the 2 arity function inside the third identity. And then it gets back an identity with a function that accepts one value, because we've now applied it to one value, and then it does that for the same thing for the next value, and then we get back a value that's wrapped in an identity because we used app. So that's pretty cool. I don't think hopefully that makes sense, and if it doesn't, I apologize, and I think we're gonna skip that for now, but we'll get into that a bit more as we talk about, like, in the series when we get into the Fantasyland specification, because I think in order to sort of generalize what we just said, if you can generalize what we just said, I think probably then you've understood lift, right? I don't understand lift, which is why I can't tell you now in a very short way. But again, if we jump back to the source code here of that function, I mentioned that they're lifting or, which is a 2 arity function, and then they are applying the function. Yeah, okay, sorry, it's not a function. They're like, f is not a function in this case. It's just that it's a function if you're passing 2 predicates. But then value 1 and value 2. So they're lifting a 2 arity function into. Yeah, the question is, like, I guess. Yeah, I don't know, dude. I don't know, because every time people say lift, they say lift it into another category. But what's this category that we're lifting it into? Who knows, man? Anyways, but yeah, I guess like the what happens is something like what we said, right? Where it's like you have a boxed value, and a boxed function. The boxed function has an arity of 2, so and it is an applicative functor, so hence it implements the function app. So you call app on the boxed function and pass a boxed value, which gives you a new boxed function which has an arity that is 1 step lower. So you get a new boxed function that only now takes a single argument. And then you pass another, like the last boxed value to that boxed function that now has an arity of 1. And then of course you get back a value, and then hence you get back a boxed value. And yeah, it just seems to me that that's sort of what has to happen, and that's why you need both of and you need app, and which is why it needs to be both an applicative and not just or that's why it needs to be an applicative and not just an apply. But again, as we talked about last time, it seems that you could sort of hack up the implementation of apply by considering constructors first-class citizens that you can pass around. But I don't know, maybe there are some good reasons for why you don't want to do that. If nothing else, I guess for like using extra syntax. But anyways, And yeah, it seems that if one understands the generalization of what we just described, it feels like then we probably understand lift. But that's something for another time. Okay, let's now we've done either. Let's now do the same thing for both, right? So let's paste. I'm just copying that and let's paste that in, and then let's replace either with both. So both, I mean, it's the same thing, right? Or I mean, it's the same syntax, but now maybe we should also pass true, because otherwise we won't get a true case, right? Because we are now talking about logical and. So let's do that for either as well, right? So we're passing true, false, 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 and then true, true. That's for either, and then for both we're passing true, false, 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 and then true, true. So same thing, right? Let's run that. Then you can see, okay, we get true, false, true for either. So the only false case is when both things are false. And then we do get results from calling either as well, which is, or sorry, from calling both as well, which is because, as we talked about last time, both also accepts any Fantasyland compatible applicative functor. So in that case, we get false, and then we get false, and then we get true. Why? Again, because it's logical and. We've lifted logical and. So it's like true and false yields false, and false yields false, and true yields true. And the result that we get back is boxed inside an identity. And this identity is this arbitrary, not arbitrary, but extremely silly applicative functor that we constructed ourselves. Okay, I think that wraps it up. Super cool. I actually think this was a pretty cool exercise because I learned a lot about applicative functors. And I guess now we just gotta find a use case for this. Nah, actually, let's just think about that quickly. It's like, if you have your own data structure, if you have some kind of boxed thing that you might want to combine with other things. So if you have something which can be thought of as a Boolean value, maybe that's a good way of thinking about it, right? If you have something which is more complex than a Boolean, but which can be thought of as a Boolean. So maybe that's, let's say, like we talked a bit about validation. I haven't read that article that I recommended last time, but if you're doing validation, for example, you might have something which is like a validation result that is like true or false depending on whether it's a succeeded validation or whether it's an error. Yeah, but that doesn't really make any sense. But something along those lines. Let's just think about that for now, right? So okay, so something like that. Let's say that you have something that's a carrier of a message, but also this message is either like a success message or it's a failure message. And if it's a success message, then you should treat it as something that sort of is truthy. But this, no, sorry, I'm making this... No. It's better if I'm quiet, right? Because we are still wrapping true and true. We are not wrapping complex objects. So please forget what I'm saying, right? What I should have said instead, what I should have shown is this, right? Let's say that we here, I mean, let's copy this last line. What we could do is also, instead of passing true and true, let's say, so for both, the function is short-circuited if the first value is false. So if we have something which is falsy, which 0 is, for example, then we should get back 0 instead of false. And similarly, for either, it's short-circuited if the first thing is true, right? Because if the first thing is true, we don't need to check the second thing because the first thing is already true. And hence, so if we put 1 here, for example, which is a truthy value, then we should get 1 back instead of true. So let's see if that actually works. So then this is sort of the evidence of that it's working with truthy and falsy, and that it's like which value it is returning depending on which scenario, right? And as you can see, here we get true and here we get false, but we get it as a 1 and we get it as a 0, which I guess is like foo is also truthy, I would assume. Yeah, foo is truthy and hence we get foo back, right? But empty string is probably not. Yeah, empty string is not, so then we get true back, because then we are not getting this empty string back, but instead we are getting this true value back. And I think, yeah, of course, right. So then you can think about it that way as well. So like, if this first value is false, then we need to check the second one. And so hence, if the first is false and the second one is true, and that's truthy, as in like, yeah, and that's truthy rather than true, then we get that value back, right? So here we get 1 as well. So then we get the second one, like we get the second value. And same thing for both. Let's think about that. If the first one is true, then we need to check the second one. So we can, let's say, if we have true here, then we will get back the second value if that value happens to be truthy. So if we have 1 here, then we will get back 1. Yeah, rather than what was I about to say? Rather than true, right? Let me just think. Here we have 0, and then we have 1, and then we have 1 and 1. So can I do the same thing for? No. Yeah, because then both have to. Yeah, I guess like what happens if both are false? Like if this, so in either, what if the first one is false and if this one is 0, then yeah, then we should get 0 as well. Yeah, so then we get the second one, right? So if the first one is false, then the second one is evaluated. Yeah, so that's the way we should think about either, right? It's like if the first one is true, then we get that value. But if the first argument is not true, then we get whatever the second value is, right? We get that as a return value. That's true, right? Wait, am I misstating this, right? Because like whatever we put here, we will get that back. Foo. But if I put empty string, we should get, yeah, we get empty string because that's falsy. Yeah, so we actually get the second thing back no matter what. And how do we think about both? If I pass, because we should have 3 cases here as well, right? If the first one is falsy, then we just short circuit and get that value back. But if the first one is true, then we get the second value back, no matter what as well, I guess, right? So like if this is 0 here, then we should get back 0, right. So, but I mean, in some sense that it's like getting false because we're getting back something which is falsy. But you can then think of it as that, like, if the first one is true, in all cases, you're getting the second one back. That's pretty interesting. So if you think about the functions in that sense, they're really pretty logical, right? Like, so either says that if the first value is false, then you will get back the second one. And both says if the first value is true, then you will get back the second one, regardless. But the thing that you get back can be thought of as something that is a Boolean, or like a bullish, right? It's truthy or falsy. Anyways, let's wrap this up. Now you know how to use both and either with applicative Fantasyland compatible applicative functors. Thanks a ton for watching. Sorry for splitting this into 2 videos. Remember to subscribe, hit the like button if you appreciate it, and I will see you in the next video.